Here in this video, we're going to look at simplifying multi-variable expressions. So what that means is you'll have more than one variable like x and y, or sometimes, a, b, and c, putting different variables together. And we're going to look at law of exponents, okay? So there are going to be different examples on how do we deal with exponents. So in this example right here, we're going to take the 3 and we're going to have to distribute it to everything. But we have to be careful here because especially when there's a negative. So we're going to go ahead, when we distribute it, I'm going to take the -2, put it in parentheses, and then I'm going to cube it, okay? We have to make sure we cube the -2. So basically you're doing -2 times -2 times -2. Not, this is the right way. If you don't put the parentheses, there will be -2 times 2 times 2. Here this is not the right thing that we have to multiply, okay? But anyway, if we put this in Desmos, it's going to do it like the right way, okay? All right, and then for the x, you're going to have the cubed as well, and then for the y, you're going to have the cubed as well. So the only really calculation that we have to do is -2 cubed. So I'm just going to put, don't forget the parentheses, really important, -2, and then close the parentheses, and then you can go ahead and put cubed, and that is -8. So you have -8, and then this is already simplified, okay? All right, same thing here. We're just going to distribute the 4, so I'm just going to do 2, 4. X is going to be 2 times 4. You have to multiply this. Y, 3 times 4, okay? And then 2 to the 4th power. 2 to the 4th power is 16. So that's 16. And then x, 2 times 4 is 8. Y, 3 times 4 is 12. And that's that. All right, here's a question where it's asking us if x and y are not 0. Let me tell you something here. Whenever you see this x and y not 0, for the purpose of the SOL, just ignore it, okay? Don't worry about it, because sometimes students will plug in 0 or something. Just for the purpose of the SOL, just ignore it, okay? All right. Are the expressions A, this expression right here, and B, are they equivalent? Meaning, are they the same thing? So to see that, what we can do here is we're going to go ahead and kind of simplify this using the rules for exponents, and then we're just going to see if they're the same. Equivalent means do they end up being the same? All right, so for this one, for us to distribute this 2, we have to know that it goes to the numerator. So the 2 goes to everything in the numerator, like that, and also the denominator. So let me do the numerator first. So that's 30 squared, and then x, 5 times 2. X to the 5th power squared would be x to the 5th times 2. And then y, 2 times 2. Okay, so we'll simplify that in just a second. And then you have to make sure that the 2 also goes to everything in the denominator. So that would be 6 squared, and then x squared goes to that as well. Sorry, it's too many arrows. X squared, and then y, 3 times 2. So y cubed squared is y to the 3 times 2. Okay, so that's that. Let's clean it up a little bit. 30 squared. So if I look here, they still put the 30 squared there, so I don't have to like multiply it out. I'll just leave it like that. So you have 30 squared. X to the 5 times 2 is 10. And then, that looks like a 6, 10. 2 times 2 is 4. Over. I'll just leave the 6 squared the way it is, because they have it here. X squared, and then y 3 times 2 is 6. All right, next what I want to do here is take care of this part right here. X to the 10 divided by x squared. There's two ways you can look at it. You can either do x to the 10 minus 2, you can subtract the 2, or so that would end up being x to the 8th power. Or what you can do here is you can just cancel out x2 here. If I take out x2 here, I would have x8. If I take out 2 x's from here, I would have x8. So both ways it works. And then same sort of thing here, but look what happens if I do this. If I do the numerator minus the exponent in the denominator, you're going to have y to the negative 2. And then when you have y to the negative 2, it goes in the denominator and turns positive. Okay, so that's one way you can do it. So basically you have y2 in the denominator. Or you can do it like this. If I take out y4 in the numerator and then I take out y4 in the denominator, I have y2 remaining in the denominator. Okay? I like this method better. So if you want to know how to do this better, just let me know in class and I can go over it with you again. Okay? All right, let's clean it up a little bit. So what do I have? I have in the numerator, I have 30 squared x8 over 6 squared and then y2. Okay, now let's see what is it that we want to see. We want to see if once I simplified this, is it equivalent to this? They look very similar, but they're not, right? Because I have x2 up here and then x2 down here. So the answer is no, they're not equivalent. All right. All right, number 4. Remember, we don't care, just ignore it. All right, let's do this part. So what you want to do here is you want to first do this part right here. So you want to do negative 12 divided by 6. Let me just put that in decimals. Negative 12 divided by 6 is negative 2. So negative 12 divided by 6, that was negative 2. And then over here, there is a 1. So if you take out a1 here and then take out a1 here, you would have a squared. And then here, if you take out b squared, well, it's equal to 1, b2 divided by b2, but we don't have to write anything. We'll just cancel those out. So let's see. We just have negative 2 a squared. And that's it. All right, next page. All right, when we are multiplying these two, see how I'm going to set this up. We're going to go ahead and multiply the coefficients. So you're going to do 2 multiplied by 5. And then for your exponents, you have to add your exponents. So here you have p to the first power. And then I don't have another variable p here, so I'll just say p to the first power times, and then q to the second power times q to the third power. I'll go ahead and simplify that later. And then you have r cubed times r4, and then you have the s. So basically I just put everything together, but just remember that for this part right here, we need to go ahead and just multiply the coefficients. So 2 times 5 is 10. There's not another p that I can combine that with, so I'll just bring that down. And then here you have to do 2 plus 3 for this part right here. Okay, we have to add the exponents. We usually don't write it, but that's just the process, okay? So you're going to add those two together. All right, so that's q to the 5th power. R to the 3 plus 4 is 7, and then you just have s. And that's that. Where's this? I think it's C. All right, number 6, which expressions are equivalent? So we want to just kind of look around and see which one of these gives me this back. Since for the coefficients, I have to multiply to get 6. So here 3 times 3 is 9, not 6. 2 times 4 is 8, that's not 6. It must be these two. 3 times 2 is 6, and 3 times 2 is 6. So it's either C or D. And then let's look at the exponents real quick. So right here you have, to get 4, you add the exponents. So 2 plus 2 is 4, so that looks good. And then you have for the y, it's technically there's a 1 here. So, and there's also a 1 here, so that's y2. Okay, so that's y2. That's what I have there. And then z6, so 3 plus 3 is 6. Okay, so that works out right there. Okay, all right, and that's that. See. All right, similar problem, so we're just going to multiply this out. So you have -2 times -3, so negative is positive, so that's +6, so it's between these three. But let me just go ahead and work it out. So you have -2 times -3, and then you have a to the first power times a to the second power, and then you have b cubed times b5. So that's 6, a 3, b 5, 6, 7, 8. That's that. All right, last two. For this one, which of the following is equivalent? So you have 4 minus 3. Remember, we subtract them, or if you rather just kind of look at it by canceling them out. So if you take out x3 here, x3 here, I have just one x remaining. If I take out y3 in the numerator, y3 in the denominator, I just have one y remaining. Okay, so you just have x over y. All right, last one. So remember that for your coefficients, we'll just do the regular math. You can say, you can just divide this out. So 15 divided by 3 is 5. And then for the exponents, now it's a little bit challenging to kind of just cancel stuff out if they're all negative. So you have two options. You can either do everything and then turn them into positive exponents. Yeah, let's actually just do that. So what we're going to do here is the 3, we have to go ahead and distribute it out to here. Now, since the 3 is only to this parentheses, it doesn't go to the denominator, or neither does it go to the 15. So it just only goes to the -2. So that's -2 times 3, which is -6, over. I already did this part, okay, so that's already 5. That's gone, okay. And then here you have x. You have x, -4 times -3 is +12. Okay, and remember, negative times a negative is a positive. -4 times -3 is +12. So, well, the negative went away. The only other negative that didn't go away is this -6. But to make it into a +6, you just have to move it. Okay, leave the 5 on the top, and then bring down, I have x12, I'll leave that, I don't have to move this. But here you can go ahead and bring this to the denominator and then make it a positive. Okay, so that you can just bring it down and then make it a positive. All right, and then you have 5 over, and then here, remember, when you're multiplying with the same base, you have to add the exponent. So this is 12 plus 6, which is 18. So that's my answer. Okay, that's my answer. All right, thank you.